Hello.
There we are.
You always start so happy. You're way better at transitions than I am. I'm just like, hey, hi, how's it going?
That was a good screenshot.
Last week.
That was a good one.
Hey. So hi, welcome to episode 4 where we are getting classy with classes.
We are.
We've had some basic foundations.
Yep.
Fun with functions.
Classy with classes.
No, we were stuck in loops last week.
We're stuck in loops last week?
Yeah, we're stuck in loops last week. But we escaped.
Good.
But now we're getting classy with classes.
Good.
So that's what we're doing today, right?
Yes. So we're going to look at classes today. And then there is one more episode before Christmas break. And then...
I don't know why I'm waiting. Bye. It's Christmas time.
one more episode. And in that one, we'll go back to the language itself, the tools that we're using, and more like the environment that we have. And that should set us up to get quite a bit more complicated after that one. So we have a lot of the foundation set. Anything that I'm expecting of you to know is already there. And then we can go into second and third and fourth gear and make something fun.
Sweet.
Cool.
Are we ready?
Are you ready?
I'm sure. I'm ready if you are. Going over to you first.
All right. There we are. 72, 105, 71, 97, 98, 101.
Is this just some code you made that says hi, Gabe?
This is hi, Gabe and ASCII.
Yeah, okay.
No, you don't. So, like last week, we looked at loops.
Yep.
And I gave you one very simple homework assignment.
Yeah.
Right?
Wow, how dare you? Okay, I was proud of myself for doing that. Don't.
And this week we'll look at loops. This week we'll look at loops. This week we'll look at loops. We'll look at classes.
Okay, very good. Yeah.
Very good.
We satisfied that, got out of it.
Get it out of our systems, right?
Yeah,
okay,
we're done with that.
So, ready?
Yeah, sure.
Great.
Homework review.
Oh,
snap.
There we go.
You had some questions, though.
Yeah, let's do the questions first.
Okay. Pull my notepad over here.
Good.
So you don't get to see this, though. I'm just going to read off what I wrote.
Oh, that's fine. So, we were using a loops, going around. Could you use all types as conditions in a while loop?
Yes, I tried char and bool,
Mm-hmm.
and then we used int, so we knew int worked.
Mm-hmm.
None of them returned errors.
Mm-hmm.
But I wrote that it wasn't built properly to actually have a bool.
Mm-hmm.
Is what I was trying, because I was just using what we had used from the lesson.
Okay.
To put bool in,
Mm-hmm.
but because I don't know, like bool has just true or false.
Yeah.
So is there much of a loop going on there, or just one answer?
Well, a loop is the question in the loop is a Boolean question, right?
Yeah.
We're asking if a certain int is bigger than 40, that's a true or false thing, right?
Okay.
So a loop is inherently a true-false thing.
Oh.
So if you would have a Boolean, you would just put the Boolean in there, right?
Because I wrote that, like, also, since Boolean only returns true and false, maybe it's not super useful in a loop.
Well, it's incredibly useful.
Okay.
Yeah,
well,
yeah.
I was just completely wrong. I just wanted to ask the question.
I mean, we need to learn here. If you were always correct, then why are we here?
Who knows?
Who knows?
Who knows?
So, yeah, a question in a loop is basically a Boolean question. You're asking a Boolean statement. So if you have a Boolean, you don't need to ask it any statements because it is already a Boolean. Maybe you want to ask if a Boolean is the same value as another Boolean. That might be true. You could say, is alive equal to is enemy alive? And then you keep on looping, something like that. Okay? We did this in the episode, but yeah, could you make an infinite while loop?
Yeah, if you give it if you give it a condition that can't be satisfied.
Yep. Which is one of them is like just true, the value true. So it will always, or if you have a Boolean value, then that's always true. Then yeah, it would go on forever. Could you put scopes inside of a loop?
I mean, I think the answer to the question continues to kind of just be the same, which is like where it makes sense.
Yeah.
Yeah. I also, you can have an empty scope, but then it just doesn't do anything.
Well, if you would create a variable within the empty scope,
Yeah.
it will die with the end of the empty scope. Yeah.
So just
Yeah, you can do it. Could you put a while loop inside of a while loop?
Yes. So I added another variable called int player double damage. I wrote the code out. to like first it asks the first loop. So there's a while loop, which was the basic one, which was what did we do? Enemy health is greater than no. Yeah, okay. So I need to put this actually in here. It'll make more sense when I read it in its actual format.
Yeah.
So first we had while enemy health is greater than 0.
Swap over to your screen. You have a nice view there.
That probably might be a bit easier.
Yeah.
So that while enemy health is greater than 0.
Mm-hmm.
So go into that because it's greater than 0 to start with. And then while enemy health is greater than 50,
yeah.
Enemy health is equal to do damage with the conditions
mm-hmm.
of enemy health, but enemy player double damage.
Okay.
So I was saying that if the enemy is above 50 health, I'm doing double damage to it.
Yeah, but you keep doing double damage
until it goes below 50 health, and then it moved down into the
normal
stuff
damage
below it. Yeah.
Yeah. So yeah, you could put a while loop in a while loop. Great.
Nice.
That worked. Could you put a while loop inside of a function?
Yes.
Mm-hmm.
It worked, but no clue how to make it work. That's what I wrote.
But yeah, it works. You can put a while loop inside of a function. A loop can be anywhere, basically.
Yeah, I wrote just I have no idea how to make it actually work to make something useful.
Mm-hmm. That's fine. Cool. So we had 2 questions. Create a loop that goes through the entire alphabet from lowercase a to lowercase c. And then the same thing, but then we go back to uppercase A and uppercase C, and it's only one loop. That was basically the thing. So if we look at the first one, let's look at yours first.
Mm-hmm.
So you had a variable called grow. Can you scroll so it's a little bigger maybe? Yeah, cool. You had a char called grow. It had A. While grow is between tick and lesser than said, you said grow is the next letter, and I really like that you use a function to increase the value. That's really nice. You're like, hey, this is a separate thing. I can make a function out of it.
What else can you do?
You could have just said grow +1. Oh yeah. But yeah, that's fine. Like,
damn it.
No, this is good.
Yeah, but that's way easier. Grow +1.
No,
but I'm telling it, isn't that inefficient?
No. Functions aren't inefficient.
Okay.
No. It's more that you took an idea and created a function out of it, and then you reused it. It should have returned a char, not an int, but otherwise it was good.
Return
the letter function.
This one?
It returns int.
This one should be int?
No,
here should be a char.
It would be char. Well, what happens is it returns it as an int, but then you put it into a char variable. Okay. So it's like going back and forth from char to int to char.
So that's something I still struggle with. Is like, when do I what's the thing that goes here?
It's the same type. It's the same type as the return.
This one. The return.
The return. Yeah, but if it's the different type, like if you're returning an int, but in the return type you have something else, it will convert it, and sometimes that conversion is not allowed.
Okay.
Like if you're returning, or not allowed, like, but it wouldn't make sense. Like if you say like, I'm returning an int, but you put a bool there, then you're always going to get a 0 or 1.
Okay.
Yeah. Cool. Okay, let's walk to mine. Yep. So I had in main, we called it letter increment. Sure. I said while the letter increment is less than or equal to z, I incremented the letter, and then I just stored it just so I would have. I put the breakpoint on 8, and then I saw letter in the loop always increase. Yeah, that was it. Cool. So next question. Create a loop that goes through first from lowercase a to z, and then from uppercase a to z. Only one loop. So let's look at what you had.
Wait, what score did I get on that homework? Was that like a B?
Yeah.
Or did I get extra credit for using a function, but then I failed for the
B+.
Nice.
There we go.
Nice. Take it.
Same function. That's great. So you had a grower again, and then you say you're going to stop at open bracket, which is for the ASCII, it's the letter after uppercase Z. Then again, you use the function, and then you had a condition when you were greater than Z, which meant that you were at the end of the normal alphabet. You change it to an at, which is the letter before the uppercase A, incremented it once, and then, what you could have done is in line 15, you could have just said, like, it's going to be the uppercase A. Then you could have skipped line 16. Yeah. But otherwise, yeah.
Wait, really? It could just be
Uppercase A.
grower equals A?
Yep. And then you go up again. You would increment it. Go up again. Go up again. Yeah.
Oh.
Yep. No, that's good.
Yeah, except I got confused with this.
Yeah. Because
When I was doing the homework,
Yeah.
I forgot that this exists, basically.
Yeah.
When I was doing the homework, I was trying to figure out. I struggle with the idea of that you could go to something, you could ask a question that's saying while it's in this value, because I was doing like the greater or less than. I was trying to do it with greater and less than.
Yeah. You were trying to figure out how can I make it within this range.
Yeah, but the problem I had was
there were two ranges.
Exactly, there were two ranges, and one of them was before the second one.
Yeah.
So in my head, I was like, "That's not even possible. I don't understand how that makes sense."
That was one of the gimmicks with this was, we need to say there's a stop condition, and the stop condition might not make too much sense.
Because I had it work fine to go back to A, but then it just continued it never ended.
Yeah, because you always satisfied a condition that you were always bigger than capital A or something, and then you just kept on going. Cool. Yeah, it's more like a B.
Nice.
Here. Cool. If we go back to mine. So we have an int main. Again, letter increment. I have a while loop. I'll show you what's in that in a bit. Again, I'm just storing what the value is going to be so I can see it in the breakpoint. I increment the letter. So it's the same solution, basically. But then I say, if the letter increment is Z, I say back to A. So I'm going back to the first alphabet. So then I'm asking the same question. Yep.
Nice.
Cool. So
I'll give you an A+.
I don't get a grade. Cool. Sounds good?
Yeah.
Good. So, classes.
Yes, I'm just going to delete a bunch of stuff here.
So, a class is a kind of a system, you might call it a system, that allows you to group together functions and variables. That's the main idea. And a class acts kind of like a blueprint. So a class by itself doesn't do anything. So if you make a class or define a class, nothing happens in that sense. But you need to create an object from the class. So if you have a blueprint, you might say like, oh, here's a blueprint of a chair. But when you create the chair from the blueprint, you might then decide that, oh, I'm going to make it blue and I'm going to, put a nicer cushion on it. So you might change it a little bit, but you still went by the blueprint in that sense. So the class is the way for the user. It's usually called the user, which is us, the programmer, because we're the user of the programming language, to make our own types. So that's how you think about classes, as they are our own types.
But an if or an int isn't a class, or are they a class?
No, no, they're not a class. An int is a class. An int is a type.
Yeah.
Yeah. An if is not a type.
Okay.
An if is a way to
ask a question.
Yeah. So it's separate that way. But an int isn't a class. That's the difference here. An int is a thing called a fundamental type, and a fundamental type is only the value, nothing else. But a class is might be some values, and a class might be some functions, but a class is still a type. Okay? So that's what a class and int, for example, have in common, is that they're both types, and you can use them. You can use a class like you use an int, basically. So to make one, you can make an empty one. This is a class called enemy, and it has nothing. And in C++, we say class, and then the type name.
Do you have to end with the semicolon?
Yes.
Okay.
Yeah, that's just a language thing. So here the name enemy, that's the important bit. We say this is a class. Okay, what's the name? The name is enemy.
Someone in chat's asking maybe it could be defined as a user-defined type?
Yeah, user-defined type. So another way to think about, or another way to make classes is to do this, a struct.
Okay.
And that's the way we're going to use it now. I'll show you a bit later why that is.
We used this in processing, didn't we?
Yeah, we used classes in processing. There is a difference between class and struct, but it is very minimal. It's a thing that you won't notice right away. I'll show you why later. But for now, I'm going to use struct, and I'll show you why later. But think of them as the same thing. It's just a class and a structure is the same thing. Audio desync are okay if anybody else has problems. So here we have a struct called enemy, and that struct contains two variables. It is health and damage, right? So this struct is then grouping together health and damage. But like I said before, this is a blueprint, right? This we haven't actually created the variable health and the variable damage yet, which is saying that every enemy has health and damage.
What? So if this was the whole, I mean,
Yep.
obviously very simplistic code.
Yeah.
Would it not just know what health and damage are, or would it assign something to them?
If this was, if only this was the code and nothing else, nothing would happen.
Okay.
The program would be empty.
It'll just go, huh?
What you're basically saying is, you're saying that there's a thing called an enemy, and that if a thing called an enemy has health and damage, but there are no enemies in the system, nobody made one. So it's like I have a blueprint for a house, but that doesn't mean I have a house. It's just, hey, here's how you make the house. So even if this says int health and int damage, we haven't made it yet. So that's kind of the difference, is because we usually see int health and int damage means that we made a variable, but that doesn't mean that. That just means when you create enemy contains health and damage. Okay? So if you want to, yeah, you're the enemy, right?
No.
No. You'll see in a bit. So I have struct enemy. It has health and damage. And then in my main, I say enemy Gabe in line 11. And then I say Gabe.health is 100 and Gabe.damage is 50. Cool. You see that I use enemy in the same way I used int and double and float and whatever. So it comes before the name of the variable because enemy is a type. Okay? Out of focus.
Checking the camera.
There we go. So if I wanted to make another enemy, I would say enemy Ole, and then Ole health and Ole damage.
You're stronger.
A little bit. Just a little bit. You're still up there.
Optimization. Okay,
there you
you're
go.
Stronger.
But you see that I didn't have to make new variables. I just said enemy Ole and enemy Gabe, and boom, I have health and damage. And you saw from the last episode that if we wanted to make player health and player damage, we kept having to make these variables, right? But here I could just say enemy Gabe, enemy Ole, and then I have health and damage. So I've made objects from the classes. I've made the house from the blueprint. So in this case, 2 of them. Okay? And I can add functions to classes. But there's one caveat here. There's one function that is special. Well, there's a couple of special functions, but for now, there's one that's special. And that function is called the constructor. And the constructor is the function that basically creates the object, or allows you to create an object. You can have more. There's more than one constructor, but in this case, we're only going to have one. In C++, you could have many constructors, but here, only one. So, do you see any? So on line 6, so this is a function. Do you see anything missing? So we have the name of the function, right? It's the same as the name of the class, right?
Is the function itself is missing?
If we ignore that, yeah. But that's in line 10 to 13, right?
Oh, yeah, okay.
Yeah.
What's the dot, enemy dot, colon?
Let's talk about that in a bit.
Okay.
If we focus on line 6,
yeah.
If you think of that as the header of the function, like we've been doing before,
yeah.
What's missing there? There's a thing missing.
The int?
Yeah, or the return value, basically.
Yeah.
So constructors don't have return values.
Okay.
So that's one of the things that's special with them, is when you're writing a constructor, they have the same name as the class, and they don't have a return type. Because when you've created the object, there's no return. It just exists?
Yeah, it just exists,
basically. The opposite is either there or not there. If you think of it that way. So, but then we can put in arguments like any other function. Here we have 2 arguments. I call it just A health and A damage as the argument health, just to have a different name. But you notice that, so in line 9, we're actually creating the function. So there's a difference between defining the function that we do in line 6. We're saying that there's gonna be a function in the class, and that function is the constructor, and it has the name enemy. These are the 2 arguments. But then in line 9, we're making the function. So there's a difference between that saying like the class has a function in it, but I haven't made it yet. But in line 9, I'm saying here's the function.
But what happens first?
What do you mean? Which of them happens first? Or?
Yeah.
You need to define the struct first. You need to say the line 1 through 7. They need to happen first.
But when it gets to line 6, it doesn't know what that is.
It's trusting you to say like, oh, there's a function here called enemy.
So once it hits line 6, it'll go to line 9.
Well, it's not running in that sense. The code is not executing in that sense. No, you're not going from line 1 and down. This is happening before you even start the program.
So what's the function of the class in this?
In this example, the function is the constructor, and the function is in line 9 through 15.
Sorry. What is the class actually doing in this code?
It is creating the enemy.
Okay, and the enemy is what we like in line 19 and 20.
Mm-hmm.
When we say enemy, and then we can give it a name.
Yep.
So the name becomes not the type, but the
name is the variable.
Yeah, the variable.
Yeah. And then you can see that in line 19 and 20.
Enemy is technically the type.
Yeah.
It's like it's an int.
Yeah.
Okay.
And in line 19 and 20, you see that it's like we're calling a function, right? We're saying enemy Gabe, and then I'm calling a function. But what function am I calling after the variable? I'm sending in 150.
Yeah.
That is the constructor. I'm calling the constructor function.
Okay.
Okay.
Yeah, I just was connecting that enemy is the type.
Yeah.
Is the class.
Yeah. So if you think about where the program is running, the flow of the program starts from 17.
Yeah.
It always starts from main.
Yeah.
Then it goes to 18. Okay, opening a scope. It goes to 19. Okay, we're creating a type. What is we're creating the variable. What is the variable? It's called Gabe. Okay, cool. What's the type of it? Okay, type is enemy. And then it wants to call the constructor with 2 arguments. Then it would say, does enemy have a constructor that takes in 2 arguments? We then go
back up to struct enemy.
Yeah, and say, yeah, it does.
Because you named it enemy in main, it knows where to go for.
Yes, because it was made before main. So that's kind of the flow. It's kind of a going all over the place kind of flow. Cool. And the same thing with Ole. And you can see that after line 19, now I'm in line 20, I can use Gabe.damage because you have been created and you have .damage and .health. I can then use that to make myself.
Where's .damage?
Line 20 at the end.
Yeah, but where does .damage come from?
Where do you think it's coming from? So what is Gabe?
The damage?
What is Gabe?
An enemy?
What does enemy have?
But this is A health and A damage.
Ah, that's in the constructor.
But okay, so then it has health and damage equals A health and A damage.
Yeah.
So, but that's saying your conditions are 102 and Gabe.damage.
Yep.
And Gabe.damage is... Oh my god, what?
No.
But I don't know where... So I'm confused with where that even comes from.
Line 4.
Okay. But that's what I said before.
No.
The enemy has int health and int damage.
Oh, you said A health and A damage.
Oh yeah, sorry. I meant like it was in the brackets, but above that it has health and damage.
Yeah. That's where it comes from, yeah. The A health and A damage is only for the constructor, and after the constructor has executed, they go away.
But what's the point of A health and A damage then?
I'm just naming it differently. Those are the arguments when you create the type. We actually see this a bit when we play with classes in Visual Studio. So maybe it shows you better then. No, you'll see the.
Okay.
You'll
Because I'm confused with how. Is the way you identify?
No. This is good.
Put it into words.
No, this is healthy because you have a confusion between where the values are coming from,
Yeah.
who is setting the values, and where they're being stored.
Yeah.
Yeah.
And also that you can just call something variable name
Hmm?
or variable dot something.
Yeah, this is great. This is wonderful. Let's go.
I don't feel wonderful. Help me.
Learning. So I can also make another function.
Yeah.
So then I just added another function. That's the only difference here. In line 7, there again, like
Oh God, you added a void.
Yes. So here it's fine. Here it's okay, because the function is not gonna return anything. So in line 7, I've said that there's a function. It has a return value void. I can have any return value. I can have bool, int, whatever, like any other function. And here you see more of a normal. It's a void. It's the name of the function. It has some arguments, right? But then I don't make the function, and then you can see the pattern from in line 16. There I say void, but I say enemy take damage, because I'm saying this is a function in the class enemy. It's a function called take damage in the class enemy. In the same way, in line 10, I say it's the constructor called enemy in the class enemy. So it's kind of backwards. So instead of saying void take damage int 8 damage, like we did before, when we made just standalone functions, I say void enemy take damage.
But where is take damage?
In line 7.
Okay, so that's where it gets made.
Well, that's think of from line 1 to 8, kind of the interface. Usually, it's called. Like an enemy has health and damage, and it has two functions: the constructor and then take damage. But then lines 10 through 14 and 16 through 19 are the actual definitions of the functions. So here's how they look like, here's what they do, and then line 1 through 8 is the interface. Yeah, like Will said, it's the declaration.
Up until this point, I could see how things came together. I'm just like...
But then I can make the function void enemy take damage. It takes in, I call it just A damage, argument damage. And I say health is minus equal to 8 damage. Because this is a function in the class enemy, I have access to health. I have access to damage. And then in line 28 and 29, after I've created Gabe and Ole, I can say Gabe.take damage. Because take damage is a function on Gabe, and Ole.take damage, it's a function on Ole. Okay? Can we just define class functions inside the class? Yes, we can, but I'm doing this deliberately. I want to separate out the declaration and the definition, because in the next episode, we'll go into files and separating files. So that will then be way easier than this, basically. Just goes to show you don't learn coding by watching and reading, you learn coding by practicing. Exactly. You need to play with this. So, and another fun thing. So this code, right? This is an entire program. It has a main, it has a class, it has some code, right? So I made Gabe have 100 health and do 50 damage. I have me that have 102 health, and I also have 50 damage. This is the same damage as Gabe has. And then Gabe takes damage from me, and then I take damage from Gabe. So both of us took 50 damage. So here's what I did. I ran this in an online editor, and you see the bottom line, that's like the blue one.
Yeah.
I say return Gabe health plus Ole health. So I'm just adding together, after we both took the damage, what was my health plus your health, right? So that's 52 plus 50, right? And if you look at line 9 on the other side, it's the move EAX.
This is 102.
Yeah.
That's not right.
It is. It's 52 plus 50.
Oh, yeah, true.
Yeah.
Sure.
So the entire program, like all the code that we just wrote, was turned into the number 102.
Nice.
So in the executable, the .exe file that was being run, when you double click on it, there is no class, there is no struct, there is no constructor, there is no take damage function. Well,
Just 102?
It's just the value 102. because it realized what we were doing and just said, oh, I can simplify this. And then it simplified it. But still, we as programmers have this nice abstraction. We have this separation of functions and values, and we have this idea that there's a thing called an enemy and they have health and damage and whatever. And then in the end, the compilers just said, oh, it's 102. It's not always clear cut like this, but I just found this as a fun example. Yeah. Compiling inlining for the win. Absolutely. Absolutely. So, should we play with classes?
Sure.
This is one of those that you need to practice a lot with, because yeah, it might be a bit unintuitive, but once you play with it, you'll see a bit more what's going on. Cool. So we swap over?
Yes. To double coding or just?
Let's do double coding. Yeah. There we go. What's the zoom level? 200, right?
Yeah.
Yep. Cool. Okay, so let's make a class. Let's do the same thing. Let's call it enemy. So struct enemy. And then enter. Yeah. So you see it adds the semicolon for you.
Making sure my keyboard's in the right language.
I think mine is as well. Yeah. Okay, cool. And let's do the same thing. So they have health and damage. Let's do the first example that we had. So if we make enemy, and let's use Will from chat. That'll be that'll be fun. And let's not do anything else. We just say enemy Will, and that's it. And let's put a breakpoint on line 10. So what would you think? So now we go into like more intuition. We're creating a variable. It's called Will, and it's of the type enemy. So enemies have health and damage. So what do you think happens? What's going to be in our locales?
Nothing.
Nothing?
Just made up numbers?
Made up numbers. So if we had a 5 and we go into this, I might have to reset my... Yeah, I have it here. Okay.
Yeah, it's just made up numbers.
Yeah, so, but look at here. We have Will,
yeah.
But then I have to open. Let me adjust this a little bit.
Yeah.
Yeah. Watch out, I'm very dangerous. Yeah. But you can see that health and damage is not a thing on their own. They're a part of Will. So he has health and damage. So if we keep adding variables there, they will keep adding there. So if we stop this and then say will.health, you can see that if you say will and then dot, just
this
dot.
Keyboard is like just slightly different, like spacing between my keys than the ones I normally use.
If you
so, like,
if you say will and then just the dot, see what happens.
Do I have to put semicolon?
No, just remove the dot, and then add the dot. Like it's and then dot. See what happens.
Oh.
It will even autocomplete for you. These are the
need to run the program.
No. So let's say will damage is 50. Okay. And then let's make another one. Enemy. Let's use someone else from chat. Stacking. Let's do that. Stacking. And then nothing else, right? So we have will.
Then we do stacking dot.
Yeah, you can give stacking. Let's give stacking 100 health or something, but not damage, just the health. Right? Okay, so now we have will with 50 damage, and we didn't set the health on will. We have stacking with 100 health, and we didn't set the damage on stacking. So again, intuition, what's going to happen?
It's going to assign values for their damage and health, but not the other ones.
Yeah, so the other ones will be garbage, right? So if we hit F5 on that one...
Garbage.
Yeah, so if you open both, you see that they are separate. Even though both of them are of the type enemy. You okay?
Yeah, I'm just trying to line up on them.
Okay.
Just like,
Yeah, there we go. So even if both of them are of the type enemy, which is the same type, they have different values. So this is where the blueprint idea kind of comes in, where it's the different house, even though they use the same blueprint. So if we reduce the health of one of them, or reduce the damage of one of them, the other one is not affected, because they're absolutely separate that way. Great? Okay, so let's create a constructor. So just enter here. We see enemy, and then a constructor. We're going to have 2 arguments because we want to set both of them, right? We could make we can do this. We can make an empty one, and we can also make one that has only 1, right?
I just want to mention that because I've been like looking at my phone.
Yeah.
Because I asked Ella to come in here to see if there was an audio desync, and apparently there was.
Oh.
So Will was right. There was a very slight audio desync, and you know why it was?
Why?
Because that computer had the microphone enabled.
From last time.
So it was picking up the slight delay you get between that and that, rather than...
It was getting both the audios. Yeah. That's not nice.
Yeah.
No.
But that was so everybody in the chat was like, "There's no delay." Ha!
There is a delay.
Got him.
Yeah.
Anyway.
Yeah. So...
How could you follow if you were a coding noob? I mean,
you could do
maybe right now is probably like this episode and what we're covering now is not the best place to jump in.
No.
We have a playlist over on our YouTube. I think if you type !YouTube, it's gonna be awkward for people watching the VOD. There's a playlist for season 1 and season 2 over on our channel.
Yep. You can do season 1 or you can do season 2.
Start with season 2.
Yeah. Cool. So. Let's do a thing here. So I'm creating a constructor. I'm saying there's a constructor called enemy. They have to be at, and it has 1 argument, which is a health, for example. I'm only saying a health because this one is called health. I can show you later in a bit. But you see what happens now?
It's a tool.
Is if you hit save, that now these 2 will complain.
Yeah. Because
they're being created with no constructor. It says no default constructor exists for the class enemy. So that's a problem as well. Because now it says like, hey, you're trying to create will and stacking and not using any of the constructors you've created. Because if you have no constructors like this,
it goes away.
It goes away because the compiler says, oh, this one has no constructors. So I will just make them, I will just use the default one.
So how do we know that that's a constructor? Because it looks just like the variable. It just looks like enemy.
Yeah, it looks like a function.
Yeah.
Like it's almost like this, right?
Yeah.
Yeah, but it doesn't have a return value and it has the same name as the class.
Okay.
That's the only. Like
and the constructor always has to go within the class.
Yes.
Okay.
Yeah. Any function that is here needs to be within the class. So if we say int a health and int a damage, and then we want to create the function. Someone in chat mentioned like, yeah, we can do this. We can write code here, and it would work, but I'm not going to do it. It will make things a little bit more complicated because you have to make the function separately, but it will be much easier for the next episodes because you want the separation. So you
make it as easy as possible.
Yes. So here you would say enemy, and then colon, and then enemy again. And now you would just write the same thing, int a health, int a damage, and now we can actually make the function. If we don't do anything now, let's just save that one. It's going to be empty, it's going to have nothing. But it's still complaining.
Yeah.
Because we need to call this constructor. So we need to, we will call a function, we will open up the braces.
So we need to give them values.
Yeah, so let's give Will 100 health and 50 damage or something. And let's give stacking 50 health but 100 damage or something, I don't know.
Glass cannon.
Yeah. And let's remove those ones that we had before. Okay, great. So we have it like this. But you notice that it's empty. And it will even, so there's like a green underline here that the editor, Visual Studio, is even helping you. Because if I mouse over this, it says that variable enemy damage and variable enemy health is uninitialized. Because we aren't setting the values. But I want to do that now, just to show you what's happening. And let's put a breakpoint on line 12, for example. Great. So if I hit F5 on that one, so now I'm in the constructor function, right? And if you look at the locals that I have, that we have a hit damage and a health, because those are coming from the argument, right? Those are the ones in the argument in the function.
Yeah.
But we also have a thing called this,
Yeah.
which is this class. And if I open it, you can see health and damage is garbage.
Yeah.
Because we never said it.
Why is it called this?
It's this class.
What if there are multiple classes?
Well, in this class, there's only one this. There's only one Ole, even though there's multiple people.
Yeah.
Well, there's only one me, from my point of view.
But it's basically because struct enemy, the int and health there haven't been determined yet.
Yeah, but the
like this hasn't been determined yet.
Yes,
okay.
But because we're in a constructor, we are in the constructor of will. We are in this one here.
Yeah.
So the this here is wills this. And if I hit F5 again, I'm now in stacking's constructor. And then I hit F5 and we can see that they still both have garbage.
Why? What happened?
Yeah, because we never set the values. So if
we did in 50 and 100.
No, we sent them in.
Oh.
We sent them into the function, but the function doesn't do anything. So if I then say health is equal to a health.
Here. Oops, I put a random 6 there.
Random 6. Health is equal to a health. Great. And let's take away the breakpoint in 12. Well, we're seeing that we're setting health to that value.
Yeah.
And now, will and stacking, if we look at their values, both have the correct health value set, but the damage value is not correct. Because we never initialized the damage value.
And that's coming because we have now set... So this is the constructor.
Yep.
And then we set...
We set health, which is this one.
Yeah.
To whatever a health was.
This seems like it's just like a... I don't... It seems like it's just a bunch of extra steps to do something.
Well, it is an extra step to just doing this. Int health is equal to 50.
Yeah.
This is the same thing. There's nothing else happening here. Or if it's in case of will, equal to 100.
Yeah.
But this health is now inside the class. And to give it the value inside the class, we can either create will and then say will dot health is equal to 100. Again, the same thing. Because now it's the health inside of will. Or we can create a constructor, send in 100, which will be set to this value, which will be then assigned to health. So it's like there's a middleman here. It is correct.
What is the name of this again?
Constructor.
Okay, but then this is also constructor.
Yeah, this is the same function. This and this are the same function.
Yeah.
This is just saying that there's a function there's a constructor called enemy that takes in 2 arguments.
Yeah.
And here it is.
Okay.
Yeah.
And then it doesn't know that what health is equal to unless we have this in here.
Yeah, because we have to tell it. Because we could have done health is equal to 8 damage.
But see, what I don't understand is why does it matter when these are called a health and this is called health?
No, this can be called Steve and this could be called John. And here's Steve and here's John and health is equal to Steve.
But we're saying health. That's where I'm confused now. Health.
Good. So
isn't health this? It is this.
Yeah.
Yeah. So then why does it matter? Why isn't this just called health, and all called health?
Where?
That's because this.
Oh yeah. Okay. So why
do they need to be called a health and a damage?
No. Yeah. That was my way of trying to not to confuse you, which then confused you. Because, yes. No, it's fine. I did this deliberately. I can call this health and damage.
Yeah.
And I can say health, but then you have this line.
Yeah, health is equal to health.
Which makes no sense.
Yeah.
But it is correct. It is fine. Because this health is this guy here. Yeah. This health is this guy here.
Yeah.
That's why I separated them. So that's why I called it a health, because it's the health argument that's coming into the function. No. Because remember when we had add, and it took in an A and a B, right? And then I say return A plus B.
Yeah.
And then here I say int result is equal to add 10 and 20, right?
Yeah.
What's this a over here?
It's the value of 10.
Yeah, because I'm calling a function called add.
Yeah.
I'm sending 10 in here.
Yeah.
It's a here. A plus b, it's 30. Great. But wait, isn't this just a more complicated way to do this?
Yeah.
Yeah, that's the same thing. But now we've separated the logic from who's ever using it. So the same way here, that if I have a class called enemy, and I have will, I want to construct will, this constructor is just a function. It takes in two values, 50 and whatever, and I need to set them. So here I can do damage is equal to a damage. Oh, I need to rename that back. There we go. And now both of them will be set. So when I create will, I'm calling the constructor. I send in 100 for a health, 50 for a damage. I want health to be equal to a health, so it's 100. I want damage to be equal to a damage, so it's 50. And then I call the constructor for stacking, do the same thing.
Yeah, I think I'm just struggling with like the different areas of like, now we have it, what to me what it looks like two different functions in two different areas doing the same thing.
There's only one function.
Yeah, I know. But
yeah.
I'm not.
No. The feeling that you have is still correct, because you see a thing here and you see a thing here.
So what I don't understand is why. In my head, I don't understand why this exists, because this, from what we've done before, is still saying like this could just be health and damage. And to me, isn't this, if we call this enemy? Oh wait. Because if we called this enemy, they would just both be the same.
Yeah.
And now we can call it enemy will.
Yeah.
And they would both be this.
Yeah.
And then we're telling enemy will.
I love the aha moment.
Damn it.
So we could do this, and then just copy this one here.
Yeah, I just wasn't.
This is fine as well.
Yeah, I just wasn't connecting that like the whole purpose of this is to have multiple enemies.
Yep.
To have the same stats, but they're not the same.
Yep.
The blueprint.
I love the aha moments. I wanna put them on.
It's gonna take me so long to understand this though, because it's not intuitive looking at it.
No,
like it doesn't make any. It's still like, because I'm trying to apply the same logic we had before. Which is just like, it's a variable holder, it's a type or variable that holds this. Done.
Yeah,
and
but
now
it's a quite a bit of a step up, and that's fine. I don't blame you. And so there's a thing in the language, like I made the add function here before. It takes an int a and int b, and then I did this, return a plus b. Okay, so it's a function that does something. I can do this, int add, int a, int b, semicolon, and then like I'm separating out these two. This is fine. The first is saying that there's going to be a function called add. I don't know when someone's going to define it, but there's going to be one. Trust me. And then one line later, oh, here it is. It's kind of silly, but anyway,
surprise.
They could be files away, many files away. And then the same way, here we're saying there's going to be a constructor with two arguments. Trust me. And then one line later, okay, here it is. Okay, so let's make that take damage function. So we do void take damage.
So why void now?
Yeah, this is a great question.
Because void is spooky.
Void is spooky,
yes.
But we can use void here. So let's say that you send in a damage. And notice here before, in the old one, we had attack or do damage or whatever we called it. We had to send in the health, right? But since now this function is a part of the class, it has access to both the health and the damage. So we don't have to send in the health that should be taking the damage. It's already there. So if we say here, void enemy take damage, and we take an int a damage, right? I'm gonna do a new line here. I could then just say health is minus equal to 8 damage. And that's it. Again with your Heath.
Heath. Ah.
What's the name of the cat? Like Heathcat? Or there's Garfield, and then there's the other one.
I have no idea.
No, okay. But
not a clue.
Not a clue. So here, I made a function. I said like, oh, there's going to be a function called take damage. It's not going to return anything. And it takes in a variable called a damage, argument damage. And here it is. Enemy take damage, a damage, and it's just reducing health by 8 damage.
So this naming then, void enemy,
yeah,
take damage, is not the same as enemy. As in like
this
yeah.
is the same as this.
Yeah.
What we're saying is the thing after this, after the thing I've highlighted right now, is a part of the class.
So why does it need to be void?
It's the return value of the function.
Okay.
So I could say here, bool.
Yeah. Okay.
But then I'd have to say return, I don't know, true. And that's fine. But now it's going to yell at me.
Yeah.
Bool enemy take damage. It's yelling at me for something. It is saying the declaration is incompatible. Yeah. Because up here
we have void.
Yeah. So they have to match.
Yeah. Okay.
That's it. But we're not going to return anything. So here is the case where I can actually use a void function.
Someone says in chat that you sound Icelandic.
I am very Icelandic. So it was kind of deliberate why I showed the constructor first. Maybe it wasn't the best thing to do, but I wanted to at least construct the item in the beginning. But
so
here,
this is now saying that when you take damage, it's is that not equal to?
Minus equal to. But it's the same thing as saying health minus damage.
Oh, okay.
Yeah.
What? Oh, okay.
Yeah.
Got it. Yeah.
Health is equal to health minus damage.
Okay.
Yeah. So now, if I go to will, and I say, or let's do it here below everything. I say will dot, and then I see here's the damage I have access to. I have the health, and I also have take damage.
Yeah.
And then what does take damage take? Takes an 8 damage. So we say stacking dot damage, right?
Sure.
And I say stacking dot take damage, and that's will dot damage. So will takes the damage from stacking's damage, and stacking takes the damage from will's damage. A lot of damage here, but anyway. So let's put breakpoints here.
Then what was the point of this? To take damage.
Yeah,
okay, yeah, because this is saying now that the health that you're gonna get afterwards is the damage you take.
Yeah.
Okay.
Yeah. So because now this health over here is the health within the class. Again, this is the blueprint that if an enemy takes damage, the health is reduced by the argument coming in. But which one it is, we don't know until we actually run the program, right? So here we're actually running the program. We're saying will.take damage. How does take damage work? Okay, let's look at the function over here. Okay, what damage is he taking? He's taking the damage from stacking. Great. So if we do breakpoints here at the last 3 and hit F5, we will see that both stacking and will are correctly initialized.
Yeah.
Great. Let's also put breakpoints 18, 19 like in the function. Okay. That would then mean when I hit F5, I'm going into where?
Now?
Yeah, if we hit F5 right now.
Take here.
Yeah, so we go there. Whose function is this? Take damage.
Enemy.
Yeah, but who's the enemy? Who is the this in this case?
Will.
Yeah. So if we hit F5, we'll go up here.
Yeah.
So if we open up this is Will, because he had 100 health and 50 damage. But the A damage, you look here, is 100. Who had 100 damage? That's stacking. So we got the damage from stacking. Great. Hit F5 again. Health is reduced. He's dead. One shot. And then we go out. Where do we go after this?
27.
Yeah. So now Will, if I open up here, has been modified.
Yeah, he has 0 health.
Yeah. And now I do F5 again. Now I go into Stacking's version of take damage. We have health 50, damage 50. Again, one shot because they have opposites.
This is all happening so fast. You guys just hit each other at the same time.
Yeah, it's a draw.
Yeah.
And then
Except you're both dead. So.
yeah, we go back out, and there we go. So you see that I created this structure that had functions, had a way to construct them, and then when we performed the action of taking damage, it modified the values within the structure. So this is the thing that practice, you need a lot of practice in this. You can keep adding functions, you can make more functions.
Bool.
As does. You can make more functions. Yeah, but you can add more types. You can do bool is alive, whatever. Yeah. So this was a nice way of looking at it. There's only one homework, but it's a big one.
Yeah.
Are you ready for it?
Sure.
Let's go to mine. Let's go to this. So we have a few questions as usual. Can you use all types as member variables? So member variable is the variables at the top.
Which would be...
Yeah, the damage and the health.
Okay. This.
Yeah. Mm-hmm.
Okay.
Can you use all types as return variables of class functions? Like we used void here. Can you use bool? Can you use int? Whatever. Can a class have no member variables? That's a question. And what would that mean to have no member variables? Can a class have a member variable that is of another class? So can you make another class? So you'd have two classes, but the second class has the first class as a member variable. So let's say we make enemy, like we did now today.
And then you just make another enemy in there and they're the same int enemy.
No, you would make another class. Let's say that you would make let's say henchman. Okay. You would make a class called henchman. Okay. And henchman would have one of its variables, maybe it has health, maybe it has damage, and then it would have enemy, worst enemy. Okay. Like this henchman, this is his worst enemy. So you have another class as a member variable. That's one question. Can you use a class as an argument into a function? Like, could we make a function and send in enemy? We wouldn't send in int, we wouldn't send in bool, we would send in enemy. Is that possible? And can you use a class type as a return value of a function? So we would make a class that wouldn't have int add or int whatever, it would have enemy whatever the function is. So that's possible. Okay, and then the homework itself. So this is one screenshot. Great. Second one is big. Okay, but I'm only asking you to make one class. So again, in the theme of the alphabet, create a class that contains one char variable called letter, one bool variable called is uppercase, one constructor that takes in one char variable called a letter. Okay, then you would have one function that was called bool make uppercase, one function called bool next letter, and one function called void set letter, and then so you can set the letter again. So what these functions should do, so the constructor that takes in one char should set the value. So it will basically say letter is equal to a letter. It would just set the value like we did before. The function called bool make uppercase should only make the char uppercase if it wasn't uppercase to begin with. So if you would send in small a, and then you would call make uppercase, it would turn the small a into the big A.
So the if question.
Yes. And if we did that, if it did make the small a into the big A or the small n to the big N, it would return true. If it didn't do that, if it wasn't a lowercase value to begin with, it would return false. Okay? Then we have a function called next letter, and that should only go from the next letter, let's say from A to B or B to C, but only if the letter in the variable, in the class, is a letter. So if I send in A and then I call next letter, it would go to B. If I send in J, or uppercase J into the class, and I say next letter, it would be K. But if I send in curly brace, it wouldn't do anything because there's no next letter, right? There isn't, curly brace isn't in the alphabet.
I'm just lost.
It's fine. And then
because just so I like, the homework isn't just to have these exist on the paper. I'm supposed to do what you're saying now. Okay.
Yeah. So it's just one class that would do all these. Okay.
But one class that would make a uppercase, like the function is saying what what it needs to do.
Yeah.
Okay.
So the idea kind of is that the class is storing a letter, some letter, and we have a Boolean also that's saying, is this letter uppercase or not? So when you send in small a, you would say that the letter is equal to a letter and is uppercase is equal to false, right? If you send in big M in the constructor, you would say letter is equal to a letter and is uppercase is equal to true, because big M is uppercase. And if you would then call make uppercase on big M, it wouldn't do anything.
Yeah.
Because it's already uppercase.
Yeah.
But if you would do make uppercase on B, small b, functions and methods that are the same. You can call them.
So basically, the first function is going to be like, it's going to be an if statement. This is if letter is between this range.
Yep. Then make it uppercase.
Letter minus 32 or whatever the number was.
Yeah.
And then if not, just don't do anything. Letter.
Yeah, don't do anything. No, not return
you don't
letter.
even need to do anything.
No, and then if it wasn't between those two, you would return false. If it was, you changed it, and you would.
But are these functions? They're not constructors. So where do they end up going?
In the class, like the take damage. So you would have a constructor.
Okay, so they would just be called. It'd be called bool. It'd be called bool.
Whatever you call the class.
Yeah. Okay. Bool alphabet.
Yeah. And then make uppercase.
Make uppercase, and then okay.
Yeah, and then bool alphabet next letter, bool alphabet, void alphabet set letter. Yes.
Okay.
Mm-hmm.
Okay.
Yep. Sounds
sure.
Good? Sounds good.
Sure.
Mm-hmm. Okay. So, think you can do it?
No. Hey, I'm just lost, but we'll see.
We'll see.
I'll have to watch this back a few times.
Practice, man. Practice. Yeah. There was a comment here regarding methods and functions. Yeah, you can call them methods. You can call them functions. I usually just call them class functions. There's some technicality to what. If you like to call them methods, that's totally fine.
Cool.
Yeah.
But we will actually.
So there's one more episode.
One more episode.
And then we have holiday break until like the second week of January, probably. Yeah. We'll see. So this episode, the next episode will be about more about the language, the C++. We're going to be thinking about compiling files and adding more files to our project and how that works and how that's connected. So not a lot of like strict coding, more like how you can make bigger projects, basically. Because then after New Year, we will be cranking up the speed a little bit.
Oh, God.
Yeah. This is kind of a hint.
I felt like this was fast.
This is kind of a hint on that. Because, yeah, we need to keep going, man.
We're all going to die.
No.
Well, thank you, everyone.
Thank you.
But yeah, we'll be back next week. Same time, same place.
Keep practicing.
Bye.
Bye.